What's going on, y'all? Let's talk today about the quotient rule. All right, and before we go ahead and get into it, just remember, look at the bottom. If you actually, oh, okay, I see now. If you need tutoring, then you can go to this website. And all this should also be in the description of this video. Make sure you go there and schedule a free consultation um, for grade school math or even some college math. And we love to talk with you. I also have my weekly SAT, ACT math practice class that happens every week. You can go here to find that, to join that, to get that SAT or ACT math score up with consistent weekly practice. And then finally, don't forget to subscribe to this YouTube channel and to like and share this video. All right. So all the quotient rule is, well, first of all, I'm not just going to assume that people remember what a quotient is, because will always have an issue with kind of like remembering like what is quotient, because the word just looks weird. But all the quotient is the answer to a division problem. That's all it is. So it has to do with division. It's the result of doing the division problem, the quotient, the answer. All right, so the quotient rule is a way to find the derivative of two functions that are being divided. So specifically, this is how you notate that. So the derivative with respect to x of two functions, f of x and g of x, is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's it. Okay. So this helps you find the derivative of two functions that are being divided. All right, so let's go ahead and start with an example. As you see, pretty easy, pretty harmless, so to speak. All right, so we want to find the derivative of these two functions being divided, x squared plus 4 divided by x minus 3. So again, let's go ahead and apply this. It's going to be first the bottom, which is x minus 3. I would definitely recommend you put parentheses around these just to make sure that, especially if any sort of negative signs or anything come up, that you can do the right thing with them. So the bottom times the derivative of the top. The derivative of the top is, let me see, derivative of x squared is bring the 2 out and then subtract from 1 from the exponent. It's going to be 2x, and the derivative of this is 0. So it's going to be 2x. Okay, so that's the bottom times the derivative of the top minus the top. See, there's a negative that we're going to have to account for. Times the derivative of the bottom. The derivative of x is 1. The derivative of this constant is 0. So it's going to be 1. And then that's going to be all over the bottom squared. All right, so let's keep on going. So now we're just going to distribute. So that's going to be, when you distribute this 2x through this x minus 3, it's going to be 2x squared minus 6x. Now, x squared plus 4 times 1 is just x squared plus 4. So, but we need to distribute this negative through here now. So it's going to be minus x squared minus 4. It's going to be all over x minus 3 squared. All right, so let's combine like terms. 2x squared and a negative x squared is just going to be x squared. Then you have the minus 6x minus 4 over x minus 3 squared. Now you can't factor you can't really factor that top x squared minus 6x minus 4 in a way that would end up kind of dividing out to maybe take, one of these x minus 3s that's down here. So this is fine. I think the book that I got this problem out of actually expanded this at the bottom, but I don't really think that's necessary. It's just yeah, it's just not necessary. All right, so let's keep on going. Let's do another example. Remember that math, getting better at math, it's kind of like building muscle. You have to like practice at it, consistently practice at it. All right, so x to the fourth plus 3x squared minus 6 over x squared plus 1. All right, so the derivative of this function divided by this function. So that's going to be the bottom, x squared plus 1 times the derivative of the top. So let's take our time with that. The derivative of x to the fourth is going to be 4x cubed. Then you have this 3x squared. So this comes out front. So it's going to be 6x. So plus 6x. And then the derivative of this is going to just be 0. So minus the top times the derivative of the bottom. So the derivative of x squared is 2x, and then the derivative of 1 is 0. So this is 2x all over the bottom squared. X squared plus 1 quantity squared. All right, so now we got to distribute. So again, especially when you have all these variables in here with different exponents and whatnot, just be careful. Just be careful, because it can be easy to mess up the exponents, mess up negative signs, all that stuff. So right here, you have a binomial times a binomial. So we use the FOIL method to multiply those together. So you got the first, which is going to be 4x to the fifth times the outer. So that's going to be plus 6x cubed plus 4x cubed plus 6x. And then let's see. I'm going to do this in stages so it's not confusing. I'm going to multiply by 2x first, then we'll distribute the negative. So it's going to be minus, when you multiply that in there, it's going to be 2x to the fifth plus 6x cubed, and then times this minus 12x. Remember, we're going to distribute that negative next. All right, and that's all over x squared plus 1 quantity squared. All right, so now I'm going to write everything else down. Now, I would have done this in one stage, but I just want to be very clear and make sure that I write everything down here so that you don't get confused, and so you can see every step. You may get to the point. So right now I'm distributing this negative through here. Negative 2x to the fifth minus 6x cubed plus 12x. You may get to the point where you don't have to worry about that and you can kind of skip some steps, but always be careful with skipping steps. That's sometimes it's easy to make mistakes there. All right. All right, now, so let's look at these. I'm gonna use some different colors to look at these like terms. So you have the x to the fifth terms here to combine. You have the x cubed terms, this one, and this one. Then you have x terms, this one right here, and this one right here. So just make sure you count for all of those. All right, so 4x to the fifth minus 2x to the fifth, that's going to be 2x to the fifth. Then you have the x cubed terms. You got 6x cubed, negative 6x cubed. Those will cancel, but then you still have this 4x cubed. So it's going to be plus 4x cubed. And then lastly, you have 6x and 12x. It's going to be plus 18x. And then it's going to be all over x squared plus 1 quantity squared. Again, that's fine. I wouldn't necessarily expand that at the bottom unless your teacher will want you to do that. But I think they expanded it in the where I got this problem from, in the book I got the problem from. All right. So yeah, keep track of all those exponents, all those variables, all those signs and stuff like that. Just take your time. Don't try to rush through it. Just let the math, oops, I knew that was going to happen. Let the math do what it does. I may not be able to really erase that part because I wrote it too low. Come on. Can I do it? There we go. All right. One more example, y'all, and then I'll let you go. All right, so the derivative of 1 over the square root of 5t squared minus 3t plus 6. Okay, so yeah, one thing I need to do is I need to erase this because this is the derivative with respect to t. And I see with my notes, I forgot to change that in my notes. I left it as the derivative with respect to x, so it's not necessarily right, but you get the idea. All right, so you got to be careful with this. All right, so it's going to be the bottom. Now, what I'm going to do is I solve this here. Well, never mind. Actually, I'm not going to do that yet. So the bottom is going to be 5t squared minus 3t plus 6 times the derivative of the top. The derivative of 1 is just 0 minus the top times the derivative of the bottom. Remember, whenever you're taking the square root of something, it's just like raising that thing to the 1/2 power. And when it's in the denominator of a fraction, the exponent is negative. So this is like 5t squared minus 3t plus 6 to the negative 1/2 power. So keep that in mind. So bottom times the derivative of the top minus the top times the derivative of the bottom. So, okay, yeah. So let me be careful though whenever I say that. But since we're taking the derivative of the bottom, it's not necessarily that the exponent is negative in that case because we're like just looking at it by itself. We're not looking at it in the denominator, if you follow what I'm saying. So anyhow, so it's going to be, since this is to the 1/2 power, you bring that exponent out front. It's going to be 1/2 times 5t squared minus 3t plus 6 to the 1/2 power minus 1. So it's going to be to the negative 1/2 power. Okay. And then that's going to be all over the bottom square. Just keep in mind, if you square a square root, then what's left is just what's under the square root. So 5t squared minus 3t plus 6. All right, so if you see here, this 0 just kind of like wipes that part out there. So let's combine. So this is going to be equal to negative 1/2 times, let me see. Okay, yeah. So keep in mind, you have this to the negative 1/2 power, and then you have this denominator. So what you have is, let me try to make sure I'm very, very clear with this. So you have negative 1/2, and then you have, I'm going to do it like this. You have 1 over 5t squared minus 3t plus 6 to the 1/2 power. Now, the way I did that is because this is being multiplied. This is being multiplied by this polynomial to the negative 1/2 power. So I went ahead and put it in a denominator. So it'd be to the positive 1/2 power. Okay. And so then, since it's divided by this, it's going to be essentially, before I do that, I almost forgot. When you take the derivative of this, you have to use the chain rule. So yeah, I forgot to use it all the way. So you take the derivative of the outside, which was 1/2 5t minus 5t squared minus 3t plus 6 to the negative 1/2 power, times the derivative of the stuff on the inside. So that's going to be times the derivative of that is going to be 10t. The derivative of this is going to be minus 3. The derivative of this is 0. Okay. All right. All right. So yeah, I almost messed up. So this becomes, okay, when you multiply that, you have negative 1/2. You have, this ends up being 1 over 5t squared minus 3t plus 6 to the 1/2 power right here. And then times 10t minus 3. And since you're dividing by this, it's the same thing as multiplying all of this times 1 over 5t squared minus 3t plus 6. Okay. All right. Now let's combine this. Now, before I combine it though, just notice here, when we multiply this to the 1/2 times this just to the 1 power, that's going to be 1/2 plus 1, which is going to be like 3/2 power. Something to the 3/2 power is just like something being cubed and then taking the square root of it. So that's going to be, okay, I'm going to combine all of this. So you in the numerator, you're going to have 10t minus 3 over, so there's going to be negative because of that negative there. Then there's going to be a 2 times this stuff to the 3/2 power, or you can just say it like this. 5t squared minus 3t plus 6 cubed. And so that's going to be to 3/2 power times that 2. And this should be your final answer, or it is your final answer. All right. So the quotient rule is not bad. Just take your time. Pay attention to your exponents. Pay attention to your negative signs, and you should be fine. Make sure you see all of our calculus videos and all that kind of good stuff, and just do well in calculus. Calculus actually can be pretty fun, in my opinion.